Hello and welcome to our short video today. My name is Matthias Beer. I'm a product manager for oscilloscopes at Rohde & Schwarz. Today I would like to show you how you can trigger a Rohde & Schwarz oscilloscope in frequency domain. To do this, we are using a frequency hopping scenario, and we will introduce an interferer which we use as trigger source. We have here a signal generator from Rohde & Schwarz, a SMBV, which is generating our frequency hopping scenario. And we have the oscilloscope, a high performance RTP instrument, where we see already the pulse. The first thing we will like to do is we do the spectrum analysis. We calculate the FFT of this pulse. For this, I use the icon at the toolbar, the FFT icon. I press this one. The moment I press the FFT icon, on the sidebar, a window pops up where I can define the typical spectrum analysis parameters. In our case, it is the center frequency, and it is 2.75 gigahertz, and we would like to do the analysis with a span of, let's say, 100 megahertz. Resolution bandwidth 1 megahertz is fine, and in order to limit the FFT to the pulse width, I simply draw a rectangular frame, and this is doing now automatically a gated FFT. What we see here at the bottom of the display is the FFT of our pulse, and this is already pretty fast. You see the update rate of the FFT from a Rohde & Schwarz oscilloscope is pretty high, otherwise we would not be able to display this frequency hopping scenario. Now what we are doing, we are introducing now interfere, our second signal, our interferer. For this I turn on my second generator, and this second generator is generating a pulse with a frequency of round about 1 second. We see the small interferer here at the lower end of the spectrum display. And now what we can do to trigger on this signal, we use the zone trigger. The zone trigger, this is a unique feature we have introduced for our oscilloscopes, which allows you to do a trigger in time but also in frequency domain. And we do this, we use the icon at the toolbar, then again a window pops up on the sidebar, and this allows us to draw graphically a trigger area. And now the oscilloscope is triggering every time this zone is violated. Now we get all the acquisitions where the zone is violated. You see here always this interfering signal. A very nice feature for pulse-to-pulse analysis or interferer-to-interferer analysis is our history mode. All the acquisitions are saved in our history memory, which we can enable with pressing the history button, and then we can go into this and step through the acquisitions. This allows us to compare different acquisitions with each other and do also some time correlated, to derive some time correlated measurements and parameters. So this is the end of my video today. We have seen a frequency hopping scenario with a dedicated interferer. We were triggering on this interferer, and I hope this was useful and interesting for you. I'm looking forward to see you at our next video. Thank you and goodbye.